Students, now let us learn measures of dispersion and skewness, the next chapter as per the syllabus, and this is even the last chapter as per the syllabus that we are left out with. This chapter we have two topics combined in one chapter, that is measures of dispersion and skewness. Measures of dispersion is a continuation of what we have already learned in measures of central tendency, and skewness is little different. And measures of dispersion is very important as we expect a 14 marks compulsory question from this chapter. Why study dispersion? Um, in a frequency distribution, though the values cluster around an average, most of them differ from it. As I have even mentioned in the PPT, what you're seeing, an average such as the mean or the median only locates the center of the data, but it does not tell us anything about the spread of the data. In some distributions, the differences may be less, whereas in some others it may be more. This property of deviation of values from the average is called variation or dispersion. In order to understand this, we have to learn measures of dispersion. Students, now let us understand the measures of dispersion meaning and the need for us to learn measures of dispersion with a numerical example. Now I have put up three series on the slide. All the distributions which I have put up are not similar in nature. They differ in numerical size of their averages and in their respective formations also. Now let us observe the following series carefully. The first series, all the numbers are uniform, which is 15, 15, 15, and 15. The second series, it is 11, 12, 13, 14, 15, 16, 17, 18, and 19. The third series is 3, 6, 9, 12, 15, 18, 21, 24, and 27. Arithmetic mean and median in all the series are same, that is 15. Now let us apply the formula orally and understand. What is the formula for arithmetic mean of individual series? Summation of x divided by number of items. So now we sum the first series 15 plus 15 plus 15 for 9 times divided by 9. The answer is 15. The same way, if we apply the formula of arithmetic, if we apply the formula of median also, the answer would be 15, that is n by 2 or n plus 1 divided by 2. So what is n here? N is 9 items. 9 plus 1 divided by 2, the 9 plus 1 is 10. 10 divided by 2 is fifth item. Which is the fifth item here? The fifth item is 15 here. So arithmetic median as well as arithmetic mean, the answer are same. Now let us test the same with the second series and third series also, where the answer would be the same, that is 15. But items in the series differs widely. So the central tendency fails to disturb the scatteredness of the values. In order to measure the nature of formation, we require the average of second order in order to support the first order. The three series which are given here are constituted differently. Though their median and mean are same, the first series, which is uniformly distributed and there is no dispersion at all, whereas the second series is having some sort of dispersion from the central tendency and the uniformity is disturbed. The third series shows a high degree of dispersion and there is no uniformity among the items. Thus, we can conclude that the larger the dispersion is, the lower will be the uniformity in the distribution. What is dispersion? The term dispersion means variability or scattered pattern of things or values which measures the degree of variation is dispersion. Significance of dispersion. Under this, the first long point says to determine the reliability of an average. As in case of measures of central tendency, which was not throwing light on the formation of series through which does not give us detailed feature of observation as well, it does not establish the relationship with items. All three reasons would make the data not reliable, but whereas in case of measures of dispersion, all these three aspects, that is which shows light on the formation of series, which gives detailed information on characteristics of observation, and it even establishes the relationship with the individual items. This is the first thing which makes us rely on the average. Then the second point says that to facilitate comparison. Now let me give you an example and explain this. Under measures of central tendency, if we have to take the frequency distribution variation of age of students of a class is less than the variation in the distribution of age of employees of factory. In the first case, the value may lie between 16 to 20. In the latter, the range of variation may be 20 to 60. Thus, different frequency distribution show different degree of variation which can be seen only through comparison. Then the next point says that it facilitates control. That is the for further what we are going to learn, that is the absolute measure of dispersion and relative measure of dispersion. All that we will find out how it can enable the measure of control, or how it can facilitate effective control measures. Then it facilitates the use of other statistical measures. That is what we are going to see in further. Properties for an ideal measure of dispersion. It should be rigidly defined. The measure of dispersion should be clearly defined as to what are the observations that we are seeing and what are the numbers that we are taking, how do we measure that, and what is the formula. All these should be clearly defined. It should be easy to understand. It should not be complicated for the person to understand while they are seeing the data, or while they are seeing the answers. It should be simple to calculate. It should be based on all observation of a series. It should be capable of further algebraic manipulation. It should not be affected much by extreme observation. The term dispersion or variation or deviation is studied with reference to two measures, absolute and relative. The absolute measures are expressed in terms of original units and they are not suitable for comparative studies. The relative measures are expressed in ratios or percentage and they are suitable for comparative studies. Under absolute measure of dispersion, we will study range, quartile deviation, mean deviation, standard deviation, and Lorentz curve. Under relative measure of dispersion, we will study coefficient of range, coefficient of quartile deviation, coefficient of mean deviation, coefficient of standard deviation. In the previous slides, we have already seen what is absolute measure of dispersion. Under that, the first measure of dispersion is range. The range represents the difference between the values of the extremes, the largest and the smallest value. The values in between the two extremes are not at all taken into consideration. So this is a very easy measure of dispersion, wherein the largest value and the smallest value is considered. Let me take an example and explain it to you. Uh, there are some five frequency distributions or five series is being given, in which it says 15, 20, 25, 30, 35, 40, 45. So in this series, the highest and the lowest is considered and the range is computed. So the largest is 50 and the smallest is 15. So what is range? The difference between the 50 and 15 is the range. It is as simple as that. And there are some disadvantages, or there are the major disadvantage what we see in this is the middle or the in between series are or extremes are not at all taken into consideration. Now let me understand what is coefficient of range, which is a relative measure of dispersion. Uh, it is defined as the ratio of range to the aggregate of minimum and maximum values. It is a relative measure of dispersion and it is based on the value of range. In simple, while we are calculating, we simply calculate it as R is equal to L minus S divided by L plus S. That is what we are referring here to as a ratio of minimum and maximum values. It shows the extent of variability in relation to range of population. It should be only computed for data measured on a ratio scale, as these measurements can only take non-negative values. It may not have meaning for the data on an interval scale. Now let us understand the merits and demerits of range. It is simple to understand, it is easy to compute. These are the two merits which we are seeing under range. Why it is easy to understand and why it is simple to compute, or vice versa? This is because the formula of range is L minus S, where we are taking into consideration the maximum and the minimum values only. So it is easy to remember, easy to compute, and easy to understand also. The demerits we have listed here, around four demerits. What are those? It is not a stable measure of dispersion. Why we are calling this as not stable measure of dispersion? Because it is affected by the extreme values only. That is, we are considering here two extreme values, that is the maximum and the minimum. Two values are considered. In between we are not considering any other values, and that is why it is called as a unstable or not stable measure of dispersion. Then, uh, the next is, if there are one or two abnormal items, range will give very misleading results. So if there are anything that is added to the existing series, then the results would be misleading. Abnormal ranges, if it is brought into the normal range, or a normal range, any new thing is added to it, it will give a misleading result. It can be computed from the frequency distribution. It cannot be computed from frequency distribution with open-end classes. Why we cannot compute it? Because it is not rigidly defined, and that is why it cannot be it cannot be computed in case of open-end class intervals. Then range does not take into account of entire distribution. As we know, the formula itself says the largest and the smallest, wherein they are not considering the in between values at all, where they are only taking into consideration the two extremes. The next absolute measure of dispersion is quartile deviation or semi-interquartile range. This is called a semi-interquartile range because with some modification to the range, the quartile deviations are brought into picture. The sum modification is nothing but here again we are considering the largest value and the smallest, but in the name as quartile 3 and quartile 1. The items below the lower quartile and the items above the upper quartile are not at all included in the computation. Thus, we are only considering the middle half of the distribution. The range so obtained is divided by 2 and we are considering only half of the data. Thus, the quartile deviation measures the difference between the values of Q1 and Q3 and it is symbolically denoted as QD. Now, let us also understand what is our coefficient of quartile deviation. It is again the ratio of QD to half of the aggregate of minimum and maximum quartile values. The formula says that Q3 minus Q1 divided by Q3 plus Q1. It is also known as a 50% zone. It is a measure of location as well as a measure of dispersion. Let us learn the merits and demerits of quartile deviation. It is easy to understand and calculate is the first merits that we are seeing under quartile deviation. As we all know, computation of quartiles under mean and in measures of central tendency is easy. The formulas we are already well versed with. Apart from formula, it is easy to compute as it is involving two or three simple process. That is, it may be arranging the data in ascending and descending and uh, finding out the cumulative frequency and applying the formula. So this is a simple procedure and it can be understood by anyone and it is easy for arriving at the answers too. And it is also considered as a better measure than range because in range there are only two extremes which are concerned. Apart from two, in between are not at all taken into consideration, but in this case it is the first quarter and the last quarters are taken into consideration, and this is why this is called as a better range when compared to uh, range. Then it is not affected by extreme values because the variables is concerned with the central half of the portion of the distribution. So this is not affected as much as it affects in case of range. It can be found graphically. We have already dealt with histograms and ogives in case of median, and it is when median can be plotted, this is the quartiles can also be plotted even on graph. And the next that we are going to see is demerits. Quartile deviation is affected considerably by fluctuations of sampling. If there are something which is brought into the series, it obviously fluctuates. The results will obviously fluctuate. And the quartile deviations are not capable of further mathematical treatments because of fluctuations in sampling, and it only considers the lower quartiles and the above upper quartiles. That is why this is considered to be not good for further mathematical treatment. Mean deviation is the average difference among the items in a series from the mean itself or median or mode of that series. It is concerned with the extent to which the values are dispersed about the mean, median, or the mode. It is found by averaging all the deviations from the central tendencies. These deviations are taken into computation with regard to negative sign. Now let us understand and learn the merits and demerits of mean deviation. It is rigidly defined and it is easy to calculate and can be easily understood. All three I will put together and explain it to you. As we all know, there are separate formulas to find out for mean, median, and mode, and all these are rigidly defined, and it is there are clauses to understand and apply the formula too. And in case of mean deviation, it takes into consideration all the items and gives weight to deviations too, and it is less affected by the extreme items as compared with the standard deviation. We have not yet dealt with standard deviation. When we are dealing with it, when we are trying to understand, we will understand the statement much better. And then, what are the disadvantages? Let me understand. It is not suitable for large samples. Uh, Then it is not accurate measures of dispersion, specifically where it is computed from mode. As we know, measures of central tendency itself does not give accurate information or accurate answers, and which is based on averaging of the measures of central tendency. The accuracy is also not perfect, and it cannot be completed for distributions with open end classes. So these are the disadvantages what we see in this mean deviation. Standard deviation is introduced by Carl Pearson in 1983. Carl Pearson name is now by now familiar for all of us because we are seeing Carl Pearson's formula in correlation, and now again even in standard deviation. Let me give you a hint. In 14 marks problem, as I said, what we get from measures of dispersion topic is generally seen from no other topic, just it is from standard deviation. And now let me explain what is this. Standard deviation is the root of the sum of the squares of the deviations divided by either number. It is also called as mean error deviation, mean square error deviation, or root mean square deviation. It is a second moment of dispersion. Since the sum of the squares of the deviations from the mean is minimum, the deviations are taken only from mean but not from median or mode. And the standard deviation is denoted by Greek letter sigma, and this is very rigidly defined and it can be applied, and the observations what is considered for computation is generally on all the series what is given, and this is widely useful measure of distribution. This is basically calculated from arithmetic mean, whereas in mean deviation we would see mean, median, or mode, but in case of standard deviation it is only mean. And in precise I could tell this as a step deviation method. Whatever we follow, more or less the same formula we will have to apply, and we have to find out the standard deviation. Once we are solving the problem, you will find it much easier in understanding what is standard deviation and why is it widely accepted also. Now let us see the merits and demerits of standard deviation. The first merits we see in this is it is a value. It is based on all observations of a series, and it is definite. It is well-defined measure of dispersion, and it is capable of further algebraic manipulations too. That is in case of the class intervals width is changed, it can be applied, but the answer would be more or less the same. And it is also very less affected by the fluctuations of sampling what we take, because we are taking here average. So here we are considering if there is an increase in data and the number of items, both are increasing simultaneously or decreasing simultaneously, and the answer would not be affected as much as it is affecting in other measures of dispersion. So the degree of scatteredness is less or minimum in case of standard deviation, and this is very widely accepted in biological statistics studies, and this is of great importance when we are making comparison between variability of two series. Then there are some demerits also in this. It is affected by extreme values like mean deviations. If we are taking mean deviations, if you are taking by computing whether the decimals are there or the assumed mean what you are taking, it affects and it gives us slight varying answers, and that is why it is said to be an extreme values, and that's how it may affect. Then it is neither easy to understand nor so simple to calculate. uh, as we know, the formula itself is big, and the number of columns that we have to put in, the number of rows we have to put in are all more, and it requires little understanding capabilities to arrive at the answers. Lorentz curve is a graphical measure. The graphical representation of the data can be presented, and this is useful in expressing the cumulative manner of data. In simple, it is used to represent the median quartile data. We have already learned this in the previous chapter, measures of central tendency, how to use Ogive's histogram to represent the data, and the same can be applied even in the measures of dispersion in case of mean deviations, quartiles as well. And as we know, it is specifically useful in comparing the variability, that is, it aids in comparing the two distributions. Students, we are done with the measures of dispersions theory part. Now we will understand whatever that we have learned in theory by applying the same in solving problems. I would like to repeat here again that standard deviation is very important, as we are expecting a 14 marks question. If you go through your previous year question papers also, 14 marks question is from measures of dispersion. Let me solve together, understand together. Thank you all.